Welcome to the detailed demonstration of My Pharmacy app. This innovative application was developed using Android Studio, integrating Google's machine learning kit for efficient barcode scanning and SQLite for robust local data management. My Pharmacy app is specifically designed for pharmacies to streamline product management. It allows owners to efficiently handle stock, while users can easily scan barcodes to access detailed product information. This app simplifies inventory management and enhances customer service in a pharmacy setting. The app's core components include Google's machine learning kit for precise barcode scanning, ensuring quick and accurate product identification. SQLite serves as the local database, enabling effective management of product stock through create, read, update, and delete operations. Additionally, SharedPreferences is utilized for managing user login sessions, ensuring a seamless user experience. The app supports two distinct operator types, owners and users. Owners have access to comprehensive functionalities for managing product inventories and overseeing operations. Users, on the other hand, can scan barcodes to retrieve product details, making it user-friendly and efficient for everyday use. Throughout this demonstration, we will explore the technology stack, delve into the codebase, and understand the app's functionality. This project has been a valuable learning experience, showcasing the integration of advanced technologies to solve real-world problems in pharmacy management. In the world of mobile app development, choosing the right tech stack is crucial. Today, we'll explore three essential tools: Android Studio, Google ML Kit for barcode scanning, and SQLite database. Android Studio is the official integrated development environment for Google's Android operating system. It provides developers with a robust platform for building, testing, and deploying Android applications. With features like code editing, debugging, and performance tooling, Android Studio streamlines the development process. Its user-friendly interface and extensive library support make it a preferred choice for developers aiming to create high-quality apps efficiently. Google's Machine Learning Kit, or ML Kit, offers a versatile barcode scanning feature that enhances app functionality. This tool allows developers to integrate barcode scanning capabilities into their apps with ease. It supports a wide range of barcode formats, ensuring compatibility with various use cases. By leveraging machine learning, ML Kit provides accurate and fast barcode recognition, making it ideal for applications in retail, logistics, and more. SQLite is a lightweight, serverless database engine that is widely used in mobile applications. It is embedded directly into the app, eliminating the need for a separate server. SQLite is known for its reliability and efficiency, making it perfect for handling local data storage. With support for SQL syntax, developers can perform complex queries and manage data seamlessly, enhancing app performance and user experience.
We'll start by discussing the tech stack used for the development of this app. 1. Android Studio. I used Android Studio as the primary development environment. Its support for Java/Kotlin and integration with Android emulators made it a great choice for app development. I also used the built-in emulator to test most of the features, but for barcode scanning a physical device is required. ML Kit's barcode scanning API supports a wide range of barcode formats including QR codes, EAN13, which is commonly used for retail products, UPCA, another retail format, Code 128, often used for shipping labels, and several others like PDF 417, Data Matrix, and ITF. To get started, the first step is to add the necessary dependencies for ML Kit in your project's build.gradle file. Head over to your app-level Gradle file and add the following implementation line. This library gives you access to Google's powerful on-device barcode scanning, allowing you to detect barcodes in real time without sending data to the cloud. Once the dependencies are set, you can start building your barcode scanning functionality. Stay tuned for more details on how to initialize the scanner and capture results from various barcode formats. API implementation. In my code, I've integrated ML Kit by adding the dependency to the build.gradle file and initializing the barcode scanner in the Add Product and Update Product sections. I'll show you how the barcode detection works in a bit. Now, I'll walk you through the basics of using SQLite in Android Studio, and we'll be referring to the official Android developers documentation. I've already opened the SQLite page here, and we'll go over some key sections together. First, let's start with the overview. SQLite is a lightweight, self-contained database engine that's embedded right into Android. It doesn't require any separate setup or server, which makes it a great solution for handling local data storage on your device. You can use it to store structured data, and it's especially useful for small to medium-sized datasets, like user preferences or app-specific data. Moving on, Android provides several key interface classes to work with SQLite. The most commonly used one is SQLite Open Helper. This class is designed to help manage the creation, opening, and versioning of your database. It's really convenient because you don't have to worry about manually handling version changes or creating the database structure. You simply extend this class and override its onCreate and onUpgrade methods to set up your tables and manage version upgrades. Another essential class is SQLite Database. This is the class that allows you to perform your CRUD operations: create, read, update, and delete. It provides methods like insert, update, delete, and query, which let you easily manipulate data in the database. Whether you're working with raw SQL queries or helper methods, this class will be at the center of your database operations. Next, let's talk about some common exceptions you might encounter when working with SQLite. As with any database, things don't always go smoothly, so it's important to know what to expect. The main exception class is SQLite Exception, which is the base class for all database errors. Then you have more specific exceptions like SQLite Constraint Exception, which occurs when you violate a constraint, like trying to insert a duplicate value into a column that has a unique constraint. Another one to be aware of is SQLite Disk.io Exception, which happens when there's an issue accessing the disk, for example, if there's no storage space left. So in summary, we've covered an introduction to SQLite, its key interface classes like SQLite Open Helper and SQLite Database, and the common exceptions you may run into. In the next part of this series, we'll get hands-on and actually create a database, write some SQL queries, and learn how to interact with the data programmatically in your Android app. Database operations. I've implemented the standard CRUD operations: create, read, update, and delete. Each operation interacts with the database to store and retrieve data. I'll explain how I wrote these queries in my code shortly. Now to use shared preferences to keep users logged into the app. Shared preferences is a lightweight way to store key value pairs, ideal for saving user session data locally on the device. After a user logs in, I store their login status using shared preferences editor by setting a Boolean flag, is logged in, to true. This value is checked every time the app is launched to determine if the user is already logged in. If so, the user is automatically directed to the home screen, ensuring a smooth experience without requiring repeated logins. Now, let me describe the Codebase extensively. This is the layout folder, where the activity main page is open. It includes 3 components: 2 buttons, one for user and one for owner, and a time-dependent text box for greeting, which I'll show in main.java. I've used an AI-created pharmacy-themed warm background that looks visually appealing. In the owner register page, there are titles with corresponding placeholders and hints for entering name, password, email, and an owner key. This can be used to enhance functionalities later. A register button is provided, and the background has a gradient from black to white. In the owner login page, placeholders are available for name and password. There's a clickable Forgot Your Password text that navigates to the Forgot Password page, along with a login button. Register links to the owner's registration page, and there's also a Delete Data button. Here's the owner screen, featuring a greeting title and 5 options, along with a logout button. I missed adding a content description to the logout image, let me correct it. But it's still clickable. The background uses a black to white gradient for white space, while buttons have a deep blue-purple to light gradient. In the owner view page, there's a placeholder and 2 buttons: search and view all. In the owner add page, you'll find placeholders with titles and hints for entering name, barcode capture, expiry, and discounted prices for small and bulk quantities, alongside an add button. The Update product page has 4 placeholders: scan barcode, unchangeable, expiry, and updated discount prices for small and bulk quantities. In the Delete product page, there's a placeholder for the product name and a delete button, again with a black to white gradient. Now for users. Here's the user register page, with 3 placeholders: name, password, email, and their hints, plus a register button. The user login page features placeholders for name and password, with a login button. In the Forgot Your Password page, placeholders for name and email are present, along with a Get Password button. Here's the product list item page, where I used a linear layout with rounded edges. Titles are runtime edited to display product details dynamically. Finally, the user screen includes a placeholder, a button, and an empty text box where product info will be shown. Now, we'll check the .java files for these layouts. We have the main activity class for our My Pharmacy app. The layout contains two main buttons, one for the owner and one for the user, alongside a dynamic greeting text. First, we check if the user is already logged in using SharedPreferences util. Depending on whether the logged-in user is an owner or a regular user, they are redirected to their respective screens, owner_CRN or user_CRN, and the main activity is closed to prevent navigating back to it. Next, we set up the layout with Set Content View. The greeting text is dynamically generated based on the current time of day using a calendar instance. If it's morning, afternoon, or evening, the appropriate greeting, good morning, good afternoon, or good evening, is displayed in the text view. Now, for the owner and user buttons. If an owner or user is already logged in, clicking the button will take them directly to their respective screens. Otherwise, the app redirects them to the login pages, where they can log in before proceeding. Additionally, we use window insets to ensure proper padding for system bars like the status bar or navigation bar, enhancing the app's layout compatibility across different devices. In this section, we focus on the owner registration screen. The layout includes text fields and labels where the owner can input their name, password, owner key, and email to register an account. The registration process is managed by the ownerAuthDB helper class. We initialize the layout components like the text fields and labels using findViewById. These are used to capture the owner's input data. The register button is also set up, and we attach an on-click listener to handle the button click event. When the owner clicks the register button, the app collects the input from the edit text fields. Before proceeding, it checks if all the required fields, name, password, owner key, and email are filled. If any field is empty, a toast message is displayed, prompting the user to complete the form. If all fields are filled, the registration details are passed to the ownerAuthDB helper class, where the database helper function attempts to save the owner's information. Upon successful registration, a success message is shown, and the app redirects the owner to the login screen for authentication. If the registration fails, the app displays a failure message, indicating that the registration process was unsuccessful. In this section, we focus on the owner login screen of the app. The layout includes text fields for the username and password, a button for login, and additional options for registering a new owner or deleting all past data. It also features a Forgot Your Password link that navigates to a password recovery screen. The app first initializes the components using findViewById. When the login button is clicked, the app checks if the username and password fields are filled. If either is empty, it displays a toast message prompting the user to complete the fields. Next, it attempts to log in the owner using the credentials provided. The login validation is done using the ownerAuthDB helper class. If the credentials are correct, the app saves the login status with SharedPreferences and redirects the owner to the main owner screen. If the login fails, it shows an error message, asking the user to check their details or register. The register button opens the registration page for new owners, and the Delete Past Data button opens a confirmation dialog. This dialog warns the user before proceeding to delete all stored data, including owner, user, and product records, using the respective database helper classes. Finally, the Forgot Your Password link redirects to the password recovery page, allowing the owner to retrieve their password. This screen represents the owner dashboard where owners can manage their inventory and perform various actions related to product and user management. The dashboard displays a welcome text, several buttons for operations, and an image view used as the logout button. The Add button allows the owner to add new products to the system by redirecting to the owner_add activity. The View button takes the owner to the owner_view activity where they can see all the products added. The Update button allows the owner to update existing product details by navigating to the owner_update activity. The Delete button opens the owner_delete activity, which lets the owner remove products from the inventory. The User Register button redirects to the user_register activity where the owner can register new users. Next, the Logout button is implemented as an image, and when clicked, it triggers a logout confirmation dialog. If the user confirms the logout, it clears the login session using the SharedPreferences util and redirects the owner back to the main activity. This ensures that the user is logged out completely and can't return to the dashboard without logging in again. This intuitive dashboard simplifies product management by providing quick access to all key operations directly from the owner's home screen. SharedPreferences util Java manages the login state of both the owners and users in the application. It provides methods to save, retrieve, and clear login-related data using shared preferences in Android. Key components. Shared preferences name. The preferences are saved under the name loginprefs, which acts as a storage for login information across sessions. SetLoggedIn method. This method takes in the context a Boolean to track if the user is logged in, and the user type, either owner or user. It saves these values in the shared preferences so that the app can remember the login state and type of user even after closing or reopening the app. IsLoggedIn method. This method checks whether a user is currently logged in by retrieving the Boolean flag saved in the preferences. If no login information is found, it returns false by default. GetUserType method. This method fetches the type of user, either owner or user, from the shared preferences. This helps differentiate what type of user is logged in so the app can show different screens based on the user type. Logout method. This method clears all saved data from the shared preferences when a user logs out. It resets both the login state and the user type by calling editor.clear and applying the changes. The owner_add.java class is responsible for adding new products to the database in the app. The owner can input product details like name, barcode, expiry date, and prices for small and bulk quantities. Additionally, the class integrates barcode scanning functionality using Google's ML Kit. Key components. UI elements. Text views and edit texts are used to display the labels and allow user input for product details, such as product name, e_name, barcode, _scan barcode, expiry date, _expiry, and discount prices for small, _DPS, and bulk, _DPB, purchases. A button labeled Add is used to submit the product data to the database. Database connection. The class uses dbConnect to interact with the SQLite database. This database handles CRUD operations like adding, updating, and deleting products. Barcode scanner. The class uses Google's ML Kit barcode scanner through GMS barcode scanner. The initialize Google Scanner method configures the scanner to scan UPCA barcodes and automatically zoom when detecting a barcode. The start scanning method initiates the barcode scanner and updates the e_scan barcode field with the scanned result. In case of failure or cancellation, appropriate toast messages are displayed. Product insertion. Upon clicking the Add button, the class performs the following steps. Collects user input from all fields, name, barcode, expiry, and prices. Calls the Validate Inputs method to ensure all fields are filled correctly. The barcode must be a 12-digit integer. The expiry date must follow the format dd/mm/yy. Prices should be valid numeric values. If validation passes, it checks whether the product already exists using the isProductExists method, which queries the database for the barcode or product name. If no duplicates are found, the product is inserted into the database, and a success message is shown. Otherwise, an error message is displayed. Input validation. The Validate Inputs method ensures that all input fields are filled correctly. It verifies that the barcode is exactly 12 digits. The expiry date follows the correct format, and both price fields contain valid numbers. Clearing input fields. After successful insertion, the Clear Fields method resets all input fields to be empty, ready for the next product entry. Overview. This class provides an interface for the owner to update a product's expiry date and discounted prices for small and bulk quantities by scanning the product's barcode. Key components. UI elements. Text views and edit texts. These are used to display the labels and take input for the product's barcode, _capture barcode, expiry date, _expiry, price for small quantity, _UPS, and price for bulk quantity, _UD. Button. The update button triggers the process of updating the product details in the database. Database interaction. The class uses dbConnect to interact with the SQLite database, where the product data is stored. The fetch product details method queries the database for the product details based on the scanned barcode and populates the UI fields if the product is found. Barcode scanner. Like the owner_Java class, this class uses Google's ML-Kit barcode scanner. The initialize Google scanner method sets up the scanner to scan UPCA barcodes and autozoom when detecting a barcode. The start scanning method triggers the scanning process, updates the UI with the scanned barcode, and fetches the product details for editing. Product update. Once the owner inputs new product details, they can click the update button to commit the changes to the database. The update product method from dbConnect is used to perform the update operation in the SQLite database. Key methods. Initialize Google Scanner. Sets up the barcode scanner with specific options, e.g., barcode format and autozoom. Start scanning. Starts the barcode scanning process. When a barcode is successfully scanned, the fetch product details method is called to retrieve the product details. Fetch product details. Fetches product information, expiry date, prices, from the database using the scanned barcode. If the product is found, the details are populated in the respective fields for editing. Update.set on click listener. On clicking the update button, the method validates the input fields to ensure no field is empty. Calls the update product method from dbConnect to update the product in the database. Clears the input fields if the update is successful. Workflow. Scanning the barcode. The owner clicks on the barcode input field, triggering the barcode scanner. Once the barcode is scanned, the system fetches the product details from the database. Updating product details. The owner updates the expiry date and prices for small and bulk quantities. After clicking the update button, the app validates the inputs and updates the product in the database. Handling success or failure. If the update is successful, a confirmation toast is shown, and the input fields are cleared. If the update fails, e.g., if the product doesn't exist, an error toast is displayed. This class provides a smooth interface for updating products by leveraging barcode scanning and database interaction, allowing owners to manage their inventory effectively. The owner_view.java class in my pharmacy app allows the owner to search and view product details stored in the local SQLite database. The activity provides two primary functions: searching for a specific product by name and viewing all products in the database. The class interacts with the dbConnect class to perform database operations and launches a new activity, product list activity, to display the product search results. Key components. UI elements. Edit text enter product name. A text field where the owner enters the name of the product they wish to search. Button search. Triggers the search function for the product entered in the text field. Button binvwall. Displays all products stored in the database. Database initialization. An instance of the dbConnect class is created to interact with the app's SQLite database. This class manages CRUD operations: create, read, update, delete. Search functionality. When the user clicks the search button, the app retrieves the product name entered in the enter product name field. If the field is not empty, it queries the database using db.searchProductByName, product name, which returns a list of matching products. If matching products are found, the app starts the product list activity to display the results, passing the list of products as a serializable extra in the intent. If no products are found, the app displays a No Product Found message using Toast. View all products. When the binvwall button is clicked, the app retrieves all products from the database using the db.getAllProducts method. The results are then passed to product list activity through an intent for viewing. Intent and product list activity. Both search and view all operations rely on passing a list of products as a serializable object to product list activity, which handles the display of product details. This implementation provides an easy interface for the pharmacy owner to search for specific products by name or review the entire inventory. If the owner wants to see the complete product list or find specific items quickly, they can do so by interacting with the intuitive buttons provided in the UI. The owner_delete.java class in my pharmacy app enables the owner to delete products from the SQLite database by entering the product's name. This class simplifies the process of removing products from the inventory and offers a straightforward user interface for product deletion. Key components. UI elements. Text view p_name. Displays the label for the product name field. Text view txt_delete product. Provides information about the deletion process. Edit text e_name. The text input field where the owner enters the product name to delete. Button pin delete. The button that initiates the delete process. Database initialization. The dbConnect class is instantiated to allow communication with the app's SQLite database. This class handles CRUD operations, such as retrieving and deleting products. Delete product functionality. When the owner clicks the delete button, the app first checks whether the product name entered in the e_name field is empty. If the field is empty, a toast message prompts the user to enter a product name. The delete product by name, product name method is called to search for the product by name. This method is case-insensitive, as it converts the name to lowercase for comparison. Search and deletion logic. The app calls database.searchProductByName, product name, to find matching products. If no products are found, the method returns false, and a product not found message is displayed. If one or more products are found, the app loops through the list of products and deletes each one based on its barcode. The method returns true if all products were successfully deleted. If any product fails to delete, the method returns false, indicating a partial or unsuccessful deletion. User feedback. Upon successful deletion, a message product deleted successfully is shown, and the input field, e_name, is cleared. If no matching product is found or deletion fails, the app informs the owner with a product not found message. Summary. The owner_delete.java class provides a user-friendly interface for removing products from the inventory by name. By implementing case-insensitive search and batch deletion for multiple matching products, it ensures flexibility and ease of use. The app provides feedback for both successful and unsuccessful deletion attempts, keeping the owner informed of the process. The dbConnect.java class is a critical component of my pharmacy app that handles all database interactions with the SQLite database. This class extends SQLite Open Helper, providing methods to manage the app's product database, including creating, reading, updating, and deleting product entries. Key features. Database configuration. Database name. The database is named products.db. Version. The database version is set to 1. Allowing for future upgrades. Table structure. The table products is created with columns for ID, name, barcode, expiry, dosage_serving, DPS, and dosage_bottle, DPB. The ID, name, and barcode fields are unique. Creating the database. The onCreate method is overridden to execute a SQL command that creates the products table with a defined structure. Upgrading the database. The onUpgrade method is defined to drop the existing table if it exists and recreate it, which helps in managing schema changes. Product management. Adding products. The addProduct method inserts a new product into the database. It uses content values to store the product details and returns true if the insertion is successful. Searching products. The searchProductByName method retrieves products matching the given name, using a case-insensitive search. It returns a list of product objects. Retrieving all products. The getAllProducts method fetches all products from the database and returns them as a list. Getting product by barcode. The getProductByBarcode method retrieves a product based on its barcode. It returns a product object if found or null if not. Updating products. The updateProduct method allows updating product details based on its barcode. It returns true if the update is successful. Deleting products. The delete product by barcode method deletes a product using its barcode and returns true if the deletion is successful. Additionally, the delete all products method removes all entries from the products table. Conclusion. The dbConnect class encapsulates all essential database operations required for managing products within my pharmacy app. Its methods allow easy interaction with the SQLite database, making it straightforward for the application to handle various product-related functionalities efficiently. This class ensures that the app maintains data integrity and provides a reliable way to manage the pharmacy's inventory. The OwnerAuthDB Helper class manages the database for owner authentication in my pharmacy app. It extends SQLite Open Helper to handle database creation, updates, and owner registration and login. Key features. Database configuration. Database name. The database is named ownerauth.db. Version. The version is set to 2, allowing for schema updates. Table structure. The owners table includes columns for username, password, owner_key, and a newly added email column for version 2. Creating the database. The onCreate method defines the SQL command to create the owners table with the necessary columns. Upgrading the database. The onUpgrade method handles schema changes by adding the email column when upgrading from version 1 to version 2. Owner management. Registering owners. The register owner method allows new owners to register by inserting their details into the database, including logging the registration process for debugging. Logging in. The login owner method checks if the provided username and password match an existing owner in the database. Validating owner keys. The validate owner key method checks if the provided owner key is valid for the given username, with logging for debugging. Deleting all owners. The delete all owners method deletes all entries from the owners table. Conclusion. The OwnerAuthDB Helper class provides a robust solution for managing owner authentication within the app, ensuring secure registration, login, and validation of owner credentials. Its structured approach to database operations enhances the application's overall reliability. The product class represents a product in the My Pharmacy app. It implements the serializable interface, allowing instances of the class to be serialized for storage or transmission. Key features. Attributes. Name. The name of the product. Barcode. The product's barcode for identification. Expiry. The expiry date of the product. DPS. Dosage per serving. DPB. Dosage per bottle. Constructor. The constructor initializes all attributes when creating a new product object. Getters. The class includes getter methods for each attribute, allowing access to the product's information. Conclusion. The product class provides a structured way to store and retrieve product details, facilitating efficient management of inventory in the app. The product adapter class in the My Pharmacy app is a custom adapter that extends base adapter. It is responsible for populating a list view with product data, allowing for efficient display and management of product items in the user interface. Key features. Attributes. Context. The current context in which the adapter is running. Products. A list of product objects that the adapter will display. Constructor. Takes the context and a list of products as parameters to initialize the adapter. Methods. GetCount. Returns the total number of products in the list. GetItem, int position, retrieves the product at the specified position. GetItemID, int position, returns the position as the item ID. GetView, int position, viewConvertView, viewGroupParent, creates or recycles a view for the product item. Sets the text for various text view elements in the layout product_list_item, displaying product details such as medicine name, barcode no, expiry date, price for small quantity, price for bulk quantity. Each product detail is numbered for clear identification. Conclusion. The product adapter efficiently manages the display of product details in a list format, enhancing the user experience by organizing information clearly and concisely. The Product List Activity class displays a list of products in a list view using a custom product adapter. In the onCreate method, it initializes the activity layout and retrieves a list of products passed via an intent. The retrieved products are then set to the list view adapter for display. This activity provides a user interface for viewing product details within the My Pharmacy app. The user class models a user in the My Pharmacy app, encapsulating attributes such as username, password, email, role, and an optional owner key. It provides two constructors, one for creating a user without an owner key and another for including it. The class includes getter and setter methods for each attribute, allowing for easy access and modification of user information. This structure supports the management of user data, essential for user authentication and role-based access within the application. The user_register class is an Android activity that handles user registration for the My Pharmacy app. It initializes UI components like text views, edit texts, and a button, allowing users to input their username, password, and email. Upon clicking the register button, it validates the input to ensure all fields are filled. If the input is valid, it calls the register user method from the user_auth_db helper class to save the user data in the database. If registration is successful, it navigates to the login screen and displays a success message. Otherwise, it shows an error message. The activity uses logging to record any registration failures for debugging purposes. The user_login class is an Android activity responsible for user authentication in the My Pharmacy app. It initializes UI components, including text views, edit texts, and a login button, allowing users to enter their username and password. When the login button is clicked, it retrieves the input values and calls the login user method from the user_auth_db helper class to verify the credentials. If the login is successful, it displays a success message and redirects the user to the main screen of the app, user_CRN. If authentication fails, it shows a failure message to the user. The user_CRN class is an Android activity for user interactions in the My Pharmacy app. It allows users to scan barcodes, view product details, and log out. Key features. Barcode scanning. Utilizes Google ML Kit's barcode scanning capabilities, enabling users to scan UPCA barcodes and automatically populate a text field with the scan value. Product lookup. When a barcode is scanned, the app retrieves product details from the database and displays them in a text view. If the product is not found, it notifies the user. Logout functionality. The app includes a logout button that prompts a confirmation dialog before logging the user out and redirecting them to the main activity. Lifecycle. On create, initializes UI elements, sets up the database connection and barcode scanner, and defines click listeners for scanning and logout actions. Start scanning, begins the barcode scanning process and handles the success, cancellation, and failure of scans. Display product details, retrieves and displays product information based on the scanned barcode. Show logout confirmation dialog, displays a confirmation dialog for the user to confirm logout action. This activity enhances user experience by providing seamless barcode scanning and efficient product information retrieval. The user_auth_db helper class is an SQLite database helper class that manages user authentication for the My Pharmacy app. It handles user registration, login, and user data management through an SQLite database. Key components. Database configuration. Database_name. Name of the database, userauth.db. Database_version. Version of the database, set to 2, indicating a schema update. Table_name. Name of the user table, users. Column and username, column and password, column and role. Constants for column names in the database. Constructor. Initializes the database helper with the specified database name and version. Database creation. On create, SQLite database DB creates the users table with username as the primary key, along with password and email columns. Database upgrade. On upgrade, SQLite database DB, int old version, int new version checks if the current version is less than 2. If so, it drops the existing users table and recreates it. User operations. Register user, string username, string password, string email, inserts a new user into the database. Returns true if the registration is successful, otherwise false. Login user, string username, string password, validates user credentials by querying the database. Returns true if a matching record is found, otherwise false. Delete user, string username, deletes a specific user from the database. Returns true if the deletion is successful, otherwise false. Delete all users, deletes all users from the database. Returns true if the operation is successful, otherwise false. Overall functionality. The UserAuthDB helper class encapsulates the logic for managing user authentication and data persistence in the app. It allows users to register, log in, and manage user accounts securely using SQLite. Now I will test all the functionalities of the applications. So SharedPreferences is working IE App Store's logging sessions, and now to test add functionality barcode scanner uses camera access to scan barcode which won't work on the emulator. Now I will test add functionality on physical device. Now testing view functionality on physical device. Now testing update and delete functionality. Thanks for watching.